Okay, so my next video was supposed to be about evolution, but as I was trolling the Globeheads today on the official Flat Earth versus Fear Earth discussion number 2 or whatever, which is a spin-off everyone knows of the groups that I made. Okay, so Carl Saganish is trying to claim that he did the Cavendish experiment, even though he has no proof. He doesn't even know proof that he was in college, but he says that he did the Cavendish experiment in college. And as we can see, this is what he showed right here. This is the post he posted was the Cavendish gravity experiment time lapse version 1, and then there's a version 2. Okay, now that's not the way science works. So we're gonna back up. Before even getting into that, we're gonna back up and see exactly what Cavendish himself wrote. There's tons of articles you could go down look for them, and they're all similar on the description of the actual. They're all similar at the actual description. We're gonna just jump on Wikipedia, and the reason why I'm gonna use Wikipedia. Normally I don't use Wikipedia, and I use other things, other sources that are more credible, supposedly, that come supposedly from mainstream science. So the reason why I'm going to use Wikipedia this time is for you that don't know what the Cavendish experiment is, or how it was actually done, or never even actually read anything. Like I said, most of you globetrotters have misinterpretations and misbeliefs. You're misled. That's why I explained the the naturalia filosofia of God, mathematica, the Principia de Mathematica from Isaac Newton. I explained that most of you had not even understood what he was trying to say. If you go and read it, you see that his whole point of that theory of the Principia de Mathematica is that he was trying to say that gravity was proof of God, that was a godly force made by God, created by God. That was exactly what he was trying to say. On the origin of species that Darwin wrote that a creator began evolution. His own words was, and the creator breathed life into one or several beings. So literally, a creator breathed into life one or several beings, which then began the process of evolution. He did not try to explain the Luca or any of that. Not only that, he didn't have access to the fossil records like we'd have nowadays. And by that I mean the mainstream science fossilized records. Because I'm pretty sure people that have private collections that don't match up with the mainstream collections. Okay, so here we have the Cavendish experiment. We're not even going to mess with anything else. We're going to go directly to the experiment. We're not trying to see the objective yet or anything. We're basically going to compare. First and foremost, the claim was that he had done the Cavendish experiment. So and I asked him specifically, did he replicate it? Okay, I asked him, did he replicate it? And before we even, we'll go ahead and read it, and then after that, I'll jump into what reproducibility and replication is in regards to real life science. So getting started right here, we have the experiment. It says, I'll go ahead and read it. The apparatus used by Cavendish was designed and built by fellow scientist John Mitchell just before his death. It consisted of a torsion balance made of 6-foot wooden rod horizontally suspended from a wire with a 2-inch diameter, 6 foot being 1.8 meters. 1.61 pound lead spheres, one attached to each end. Two 12-inch, 348 pound lead balls were located near the smaller balls, 8.85 inches away, and held in place with a separate suspension system. The experiment measured the faint gravitational attraction between the small balls and the larger balls. Now, when someone says, like, did you replicate that? Did you replicate this science experiment. No, none of you have replicated this science experiment. And right off the top, in the first paragraph, okay, show me your balls. You Globeheads don't have the balls. You guys don't have the balls. Literally. You don't have the balls to prove that you guys did the Cavendish experiment. Okay? Two 12-inch balls were 348 pounds each, made of lead. Okay? The other ones, let me see, a 6-foot wooden rod, 2 inches better, 358. And the other ones were 1.61 pounds, which is not much. But just the two 12-inch balls alone that's 700 pounds. All right, you guys have never picked up any weights that size. All right, it's ridiculous. So right off the bat, I'm telling you right now, you did not replicate what Cavendish wrote to do. That's his science experiment. This is Cavendish science experiment. It's in his name. He wrote how to do it. He explained how to build the whole torsion contraption. He explained how to build the apparatus, the enclosure. Okay, he described the method of procedure so you could replicate his experiment to test for the reproducibility. All right. As you can see, the drawing, the drawing of it looks pretty huge. Two large balls were positioned on alternate sides of horizontal wooden arm of the balance. Their mutual retraction to the small balls caused the arms to rotate. Blah blah blah. We're trying to see how he built it. To find the wire's torsion coefficient, the torque exerted by the wire for a given angle of twist, Cavendish timed the natural oscillation period. He manipulated it. Okay? Moving down more. Actually, the rod was never at rest. Cavendish's equipment was remarkably sensitive for its time. The force involved in twisting the torsion balance was very small. 1.74 times 10 to the negative 7, and about 1/50th 50 millionth of the way to the 50 million 6 zeros to the weight of the small balls to prevent air current and temperature changes from interfering with the measurements. Cavendish placed the entire apparatus in a mahogany box about 1.98 meters wide, 1.27 meters tall, and 14 centimeters thick, all in a closed shed on his estate. Through two holes in the walls of the shed, Cavendish used telescopes to observe the movement of the torsion's balanced horizontal rod. The motion of the rod was only about 0.16 inches, 4.1 millimeters. Okay, now look. The reason why it's important that you guys understand that right there is that I'm gonna come back to this. There's the reason why he did this. Okay, the reason why he enclosed it. Not only was he so it says to prevent air currents and temperature changings from interfering with the measurements. Right, as you guys can see, that's what it says. Okay, so what that's called, he's isolating the staging area. So when you run a scientific experiment and you have a staging area, that area must be isolated from external factors, because those external factors must have some type of effect on the results. So by him isolating his staging area in this really big wooden box and only put two little holes, and he was looking at it from, now look, when they said that he was looking at it through the telescope, It's not like he was 6 inches away looking in there with the telescope. He was looking through the telescope like 100 yards away or something. I forgot how far away he was, and he didn't just do this in like 15 minutes or an hour or one school day. Nah, he did this for months in a row. All right. He did this for months in a row. You guys comprehend that? And all right. So moving back. Let's move back now. All right. So off the top, you guys did. Most of you did like. I could be like 99% sure none of you have ever done the Cavendish experiment, because the Cavendish, we have already, just the lead balls alone, the two 12-inch ones were 300, almost 350 pounds each of weight, and there were 12. Like, where do you guys get that much lead from without getting in trouble? They will ask. People will ask, "What are you trying to do with that much lead? Why do you want it made in a specific, in a specific shape, like a spherical ball and shit?" All right, those are custom made. You're just not like you're gonna go down the street, buy a piece of lead and be like, "Oh, we're gonna use this." Nah, you gotta make sure it's 12 inches, okay, and you gotta make sure it's spherical, exactly like he did. Now we're gonna watch the video that he posted. So we've already established, no, you did not do the Cavendish experiment. I've already established and explained how the staging area must be isolated from any external variables, okay? That's the way it has to be done, all right? And I've explained one of the main reasons why is because, well, I just explained, yeah. Although anything could affect the experiment. Now, the experiment was to test if mass is attracted to mass. That's what he was trying to show. That the bigger spheres would somehow slowly pull in the smaller spheres based on mass alone. No other variables were allowed. That's why he isolated the staging area. Temperature, air, currents, and yes, dielectric potential, static electricity. If you guys don't know about Coulomb's law, then you need to look it up. Okay? Coulomb's law, okay? Okay, you guys? Now, as we watch this, we're going to watch it once totally. When we finish watching it, I'm going to back up, and then I'll explain how everything is wrong.
Okay, we're going to be trying out the Cavendish experiment here. I've been letting the torsion balance come to rest over the course of about 24 hours now. Even with that amount of time, I think just from the air circulation, from the heating and cooling system, I've still seen a small amount of motion here. So in the last about 10 minutes, I've seen this end move from here over to here. So that's probably about 10 degrees in 10 minutes. I'm going to let this, I'm going to just gently touch this and try and bring it to rest and observe for another couple of minutes. And then whichever direction I see it moving, I'm going to put the bowling balls that are my other masses on the opposite side as that, just so we can verify that there actually is a change in direction, a change in the direction of the acceleration of these things as they rotate. I don't think we're going to be able to get it to a position where they're totally stopped initially. So this seems like the best way that we can still verify that there is some force from gravity between the masses I have on the ends of this meter stick and the bowling balls that I'm going to put in place. So very gently, I'm going to be just trying to stop any motion that we have in there, just a tiny, tiny force. I'll mark where it is right now. Whichever direction I see it move in. After this, I'm going to put the bowling balls on the other side. Now, actually, I'm going to try this again. I think I gave it a little bit too much force, even with just that very gentle touch. I see it already moving quite a bit. Let's check that one more time. Okay. Looks like that's moving just very slightly, if at all, right now. I can't see any motion. So we'll let that go for a minute, see which direction side. It looks like in the time that we've let it go, it's moved from here over this way, so it's rotating counterclockwise when viewed from above. So I'm going to put the bowling balls in place on this side and that side over there, try and pull it back clockwise, and we'll see if we can get some noticeable acceleration in that direction. So it looks like we've had our first contact between the masses at the end of the ruler, the meter stick, and the bowling balls. So that's pretty exciting. We did see that motion toward the bowling balls then. Now there is still the question of where that equilibrium position was for the string. It didn't occur to me until just now, but when I marked the spot that it had started at and noticed that it had rotated this way, that could have been an effect of the velocity that I gave it initially. It may not have been accelerating that way. Maybe it would have rotated back this way on its own. So for that, we'll have to go to the video and see if we can observe some acceleration in this direction, or whether that was just my initial velocity. But right now, it looks like a successful test and a successful replication of the Cavendish experiment.
That replication.
After viewing the video, I'm really happy with the results. When I went back and looked at this, after I last touched the torsion balance, this end was moving this direction, so it's rotating clockwise. But on its own, it came to a stop and started rotating back this direction. So we must be really close to the equilibrium position on this right now. So when we started it, it was over this way, to this side of the equilibrium position, and still moving this direction. When we put the bowling balls on there, it turned around, which it would have done anyway to get back to its equilibrium position, but it went way beyond where it had gone the first time. So regardless of which direction it was moving when I put the bowling balls in there, you can see there was some clear effect of the force of gravity from those bowling balls, pulling it much, much farther than it would have gone just due to its own oscillations. So again, this is a really nice example of the force from gravity between two very small objects. A good replication of the Cavendish experiment.
Okay, so we'll back it up. And before we go any further, we're gonna, because he said replicate, right? Okay, definition. Make an exact copy of, reproduce. Okay, now we're gonna look at reproducibility. The ability to be reproduced or copied. Okay, so just on those two definitions alone, no, he did not replicate it. Okay, he did not replicate the Cavendish experiment. As we just read it, okay, this contraption, torsion contraption, is nowhere near the real thing. He's got different type of materials, different, you know, the surroundings.
Mark where
surroundings. Just back it up.
Okay, we're going to be trying out.
Okay, so the surroundings are not a perfect square. As you can see on the top left-hand corner, there's mass right there in the top left-hand corner. All right, and then where he starts standing, there's no mass behind there because the wall differences are also different. Some of the walls seem to be brick, and some of it looks like drywall.
The Cavendish experiment here, I've been letting the torsion balance come to rest over the course of about 24 hours now. Even with that amount of time, I think just from the air circulation, from the heating and cooling.
He just admitted right there there's air circulation, which totally debunked his claim that this is a Cavendish experiment, when Cavendish specifically isolated his staging area to make sure no air currents were affecting the outcome of the results.
System. I've still seen a small amount of motion here. So in the last about 10 minutes, I've seen this end move from here over to here. So that's probably about 10 degrees in 10 minutes. I'm going to let this, I'm going to just gently touch this and try and bring it to rest and observe for another couple minutes. And then whichever direction I see it moving, I'm going to put the bowling balls that are my other masses on the opposite side as that, just so that we can verify that there actually is a change in direction, a change in the direction of the acceleration of these things as they rotate. I don't think we're going to be able to get it to a position where they're totally stopped initially. So this seems like the best way that we can still verify that there is some force from gravity between the mass.
I'm glad he brought all that up, because this is what exactly the Principia de Matemática was trying to say. And if you read the actual title, it says watch. We'll go back, so you guys don't say the Principia full name. So it's called Philosophia Naturalis Principia Mathematica, all right? So that's philosophy, the natural philosophy of the principal math. That's what it's saying. Now, by principal math, what he was saying, like, where did this math, the principle of it, the principle of this math, okay? He was saying, what Isaac Newton was saying was that there's no way that gravity could have started, came from the Big Bang or any other type of creation point. That it had to have been divine. That it's so beautiful. Like the way he described gravity is so beautiful and so artistic, and the numbers were just so perfect that perfection must come from God, and that was proof of God. And he goes on to say that that's total proof of God all the way around. Okay? That's exactly what he said in that article. And if you haven't, if you don't believe me, scroll down on my videos, and you'll see where I read it. I literally open up this article and read it to you guys. All right. So moving forward.
I have on the ends of this meter stick and the bowling balls that I'm going to put in place. So very gently, I'm going to be just trying to stop any motion that we have in there. Just
manipulating the experiment, also something that Cavendish did not do. He did not jump in the enclosure and touch it and all that. He left it alone. He recorded it for months in a row, not just like 24 hours or whatever. And none of that. All right. He watched it from holes. You guys read he watched this experiment happen alone on its own. Well, with a telescope. He didn't go in there and like start poking it around and touching it and all that other crap.
Tiny force. I'll mark where it is right now. Whichever direction I see it move in. After this, I'm going to put the bowling balls on the other side. Now, actually, I'm going to try this again. I think I gave it a little bit too much force, even with just that very gentle touch. I see it already moving quite a bit.
See, behind him, there's the wall difference. See, there's a corner right there. That wall that wall has more mass than supposedly the space behind him where he's now standing at. Where
very
there's no
slightly,
mass
if at all, right now. I then see which direction it's moving.
I could clearly
and
see
put
it's
the
moving.
bowling balls on
I don't know
the
what he's talking
opposite
about.
side.
I could clearly see it's moving. Look, it's moving right there. As he walked away, it moved. And another failure right there. He puts a clock. That clock has a battery in it, and it is using an analog, is using a mechanical motion, and it is creating dielectric potential or static while it's doing so. That's what it does. All right. That right there is that little mechanical arms moving around in a certain direction. Okay, are sending off little waves, and therefore interfering and affecting this science experiment. This is a total failure.
Looks like in the time that we've let it go, it's moved from here over this way, so it's rotating counterclockwise when viewed from above. So I'm going to put the bowling balls in place on this side and that side over there, try and pull it back clockwise, and we'll see if we can get some noticeable acceleration in that direction.
It's already moving in one direction using Isaac Newton's own principles. If it's moving in one direction with force, it'll eventually come back. And I'm pretty sure, I remember he did say that later on throughout the video, that it's gonna come back. It would have came back eventually because it's actually oscillating. And as he put the balls down, we've seen it shake. It's shaking. Just back it up real quick. Watch as he walks around it and he puts the balls down. Even when he gets up to walk away, you'll see it shake. He's obviously not. See, there it is, the shaking. You could definitely see them shaking. If he's on a wooden floor, then those bowling balls are creating a little are creating weight down onto the floor itself.
So it looks like we've had our first contact between the masses at the end of the ruler, the meter stick, and the bowling balls. So that's pretty exciting. We did.
And again, we know that the bowling ball and whatever those weights are, those are not lead. None of this is made out of lead.
See that motion toward the bowling balls then. Now there's still the question of where that equilibrium position was for the string. It didn't occur to me until just now, but when I marked the spot that it had started at and noticed that it had rotated this way, that could have been an effect of the velocity that I gave it initially. It may not have been accelerating that way. Maybe it would have rotated back this way on its own. So for that, we'll have to go to the video and see if we can.
He clearly admitted it, that it would have slung back, it would have oscillated back, and we clearly seen that as he moved around and put the bowling balls down, there was definitely motion that affected it.
Observe some acceleration in this direction, or whether that was just my initial velocity. But right now, it looks like a successful test and a successful replication of the Cavendish experiment.
We already know the definition to replication, to replicate, and reproducibility, and so we definitely see he failed all the way around. All right, he did not do the Cavendish experiment. In fact, he debunked it, and I haven't even finished with you guys yet. All right. Now, a lot of these tests are done, these supposed Cavendish experiments, or whatever they believe they're claiming that they are, because they're definitely not. Okay, they're mainly done inside classrooms, all right, and they're done inside class. So the classrooms are full of all kinds of weird interferences. You know, you have electrical devices, you got clocks, you have all these other interferences that are giving off electromagnetic and electrostatic potential that surrounds that whole environment. The air conditioning itself is a controlled environment. So that also, it's not just the air currents that's going, it's actually a lot of those systems have ionized air currents. Those air currents are actually ionized, okay? Now, So moving beyond that, moving beyond just the natural environment. I mean, just the controlled environment, and moving beyond the potential that the electrostatic and electromagnetic potential from devices and electronics and whatnot. Let's talk about the mass of the human beings. So a lot of these are done inside classrooms, and the classrooms have like all the students in one side of the classroom. We have like tons of mass of people on one side of the classroom, while the other classroom does not have any mass. If this Cavendish experiment were real, then the torsion contraption would always point towards the mass of the people, the masses of students. All right. And then the students are sitting on desks. That's more mass. Okay, they have, what I mean, like they have their backpacks and their books. That's a lot more mass. So this torsion contraption ought to be pointing directly at all the mass of the students. All right, you guys are not replicating the Cavendish experiment, and what you're actually doing is you're debunking the Cavendish experiment and destroying your own ideology by doing so. Do you guys even science, bro?